into Y1 and graph and see what it looks like. Yeah? That was funny. I love that guy. This is wonderful. I'm going to go to Y1, 186 times 1/2 to the x. I remember doing this with you vaguely. Or I vaguely remember doing this with you. We didn't do it vaguely, we did it well.
Oh, where's that? I didn't know where that little exponent.
Oh, the carrot here. The carrot is right above the division sign.
Okay.
To the. Okay, I'm getting an idea for another quiz for next week. This is good. No. It's choose your own adventure, Mary. It's choose your own adventure. Do as many as you want.
It's kind of unrelated, but as far as the whole margin of error thing, I
Yes.
have an interesting quiz to do would be on voting fraud.
Oh. I was actually considering voting results from what happened yesterday for you guys.
Well, people always try to use voting fraud as an argument, but it happens literally everywhere.
Yeah.
So maybe a quiz is like.
But you know what? I love this. Anya, I hadn't thought about this. I love this. The trick is I wouldn't know how to measure it because since it happens everywhere, nobody seems to know what happens. How would you actually measure how much it's happening?
The only way is there'll be a lot of go to each person.
Voting fraud. And you see, the jury just solved the problem. The problem is the solution is painful. I've often been told we can't analytically measure the cost of living in Bend. Whenever cost of living in Bend is mentioned, they always talk about Portland's cost of living. They say, it's the same as Portland. I'm like,
Cost of living in Portland is way
it's
cheaper.
not the same as Portland. But it's too hard to calculate the cost of living in Bend. No, it's actually not. There's a calculation for creating a cost of living. It's called a basket of goods. That's a cute term. How much would a basket of goods cost? So imagine carrying a basket of milk, eggs, a house, a car.
Yeah.
I mean, you have to imagine all these things fitting in this basket. And then once you know what those cost on median in Bend, you can compare that to an established CPI like Portland. So imagine a house cost, just make up the numbers to make them easy. Suppose a house costs $100,000 in Portland, and a comp house is $200,000 here. That's a multiplier of 2. Does that make sense? Okay, suppose food costs $70 for some unit in Portland, and it costs $35 for some unit in Bend. Comparable. That's half. What you do is you look at each item in the basket in one and do a weighted average, which we're getting close to here with this data here. A weighted average of the numbers in Bend. Does that make sense so far? And then you run with that. That gives you a cost of living. But I'm always told, you can't do it. No, you can do it. You just don't want to do it. It's a lot of work to get what the comps are. And once you know what the comps are, collecting the prices are easy. But getting the comps, how do you comp Portland CPI? Well, you have to find out how that CPI was made. It's more work. It's not that it can't be done. It's that nobody wants to actually do it. So anyway, yeah, Jerry, go ahead.
I was going to ask,
Thank you,
when
Anya,
you're
for that,
looking
though.
at like the cost of houses in the area, are they looking at if each house was appraised, how much it would be worth, or are they looking at what it's selling for?
It would have to be, in my opinion, what it's selling for.
Okay.
I mean, there are people in my neighborhood on the northeast side of town trying to sell houses for $600,000, and I'm like, have a good time trying to do that while you pay yourself into the ground mortgage-wise.
Right.
So you have to do it realistically with what they're actually selling for.
Yeah.
In my opinion, this is my humble opinion as a non-economist.
Yeah.
But I mean, I could put my house on the market for $1.2 million right now and be like, well, there you go, it's appraised because I said it was. That's great. Except if you try to sell that, you get a fifth of what you're asking for. Does that make sense, Jerry?
Yeah.
Yeah, Christina, yeah.
So do they factor in salaries too? Because I know
That's part of it. Earnings.
It is.
Yes,
Okay,
wage earnings. Yep.
That's it.
And I don't know if they may even factor in more than one type of wage. It depends on, professional level wage, service level wage.
Right.
I don't exactly know.
Okay.
Minimum wage, I think, is statewide, so that's a one-for-one comparison. Yeah, I mean, if you look, do this something, if you're interested.
Salaries are
just
low
go to Google
here.
and do cost of living calculator.
Yeah, cool.
And some cities, in Oregon, I believe there are only 2 in the national database. 2 cities in Oregon. Portland and? Nope, 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 nope.
What?
Keep guessing.
John Day.
Keep guessing. Somebody just said it. Climate Falls. K
Oh my
Falls.
God.
How did K Falls get there? Somebody decided, you know what, I'm tired of being told you can't do this, let's do it. And they created a CPI for Klamath Falls. So Portland and K Falls. Now you can do it the wrong way and say, well, Ben's halfway between and take the average. You could do that. Doesn't make any sense, right, economically. So it can be, if you're interested in the calculation, and it's tedious, but what you're doing right now is way harder mathematically than what that calculation is. It just takes time. It just takes time.
Sometimes the time it takes makes it seem like it's harder.
Yes, but the time it takes is a one-time deal that then can be updated, and then you can actually use the data to make decisions. Holy shit, imagine that. Anyway, let's take a look at this bad boy. How's it look? How's it look? Oh, that's just dynamite. Looks gorgeous. And I think at this point we started Z-boxing in, we started drawing those rectangles in to see how the curve was missing. Yes, very good, very good, very good. Now what I'd like you to do, and this is what's cool about models like this, if you press the trace button, it'll drop you first onto your plot. Like when I press trace, the first thing it tells me is P1, L5, L6. Yours probably says P1, L1, L2. That's just because your data's in L1, L2, mine's in L5, L6. So it's telling me that when x equals 0, y equals 186. Well, you knew that, right? You knew that, exactly. So you can then scooch over to the right, and it will tell you when x equals 1, y equals 82. Well, you knew that too, because that was the second data point you put in, right? Now scooch up, or jump up, I should say. Notice when you jump up, why did I jump onto the curve? X equals, did yours do that too?
Yeah.
Type 1 and press enter. There, that's what I wanted to do. I'm surprised it didn't just jump onto the curve. Yes, you can. I thought you could jump to it though, Ash. I didn't realize you couldn't. For all these years I thought you could. So now, when x equals 1, y equals 93. Now that's different than 82, isn't it?
Yeah.
But that's because 93 is the predicted value from your equation. Remember, it's not exactly right. It's close to correct, yes? It's close to correct. So the equation is saying it should be 93 when our data said it was actually 82. So that's off. But as you can tell visually, it's not off by that much, right? It's not off by that much. When you plug in x equals 2, it tells you it should be 46 and a half. Now, we did not have 46 and a half flips in here. You can't have half a flip. That's like flip the coin, it stays up in the air. We don't have a half a flip, right? We had, if I remember correctly, and I don't, we had 59, which again is pretty damn close to what it should be. Now you'll notice this data point was underrepresented because the curve is above it, and the one we're on right now is overrepresented because the curve is below it. That's going to happen because that 1/2 we just described is not an absolute guarantee, it's an average. We're smoothing the data out. Yes. Fair.
Making it conform.
Making it, modeling its behavior. Can I say it a different way? Which sounds like I'm being a politician up here, but I'm not. We focused on the behavior of the data and realized it's doing that, right? We're basically losing a half every single iteration. And that's what's so nice about exponential models is they do have a predicted decay rate or growth rate. We'll look at growth rates by the end of today. There's also a growth rate that you can have. Not on this one, because it's not growing, it's falling. But certain things grow exponentially. So, at any rate, I like this for that reason. Number one, it also, since it's a half of a half of a half of a half, it's never going to come back up. It's going to keep, if anything, getting closer to 0 with every successive thing, yes? That's pretty slick. That's pretty slick. But it can never equal 0. You know, half of a half is a fourth, a half is an eighth, and then a 16th, a 32nd, a 64th, a 1/28th, a 256th, 1/1024th. I mean, you're getting very close to 0, but you're never actually hitting 0. Fair enough? Good. So it's doing everything we wanted to do. Anya, please.
I'm having a calculator. We are kind of.
What's it doing?
When I try to type 1 in and enter, it just completely.
Oh, you have to have it on trace. So when you're on your graph, press trace, you have to get onto the equation, and then do the 1 and the enter.
Okay.
Yeah, if you're on the plot, for some reason it just kicks you out. I don't know why, it just kicks you out. It should just stay on the plot. Cool, go ahead, Ash.
If we're trying to graph this, do we use exponential, right?
Yes, and thank you for the segue. That's what we're going through next.
Sorry.
So no, this is beautiful. I was just about ready to start that, isn't it? Now here's the deal. We knew what the maintenance rate was on this one because we understand coins, right? We understand that when you flip a coin, half the time you get heads and half the time you get tails. We understand that. What if it wasn't obvious what the rate was? What if, for example, you were trying to model the behavior of a charcoal filter on an aquarium? You're developing a new filter for aquariums or for ponds or for pools. And you want to be able to say, reduces blah blah % of contaminants each hour. Well, you just can't assume, I'm just going to put 50% on there and call it good. That's a good way to get yourself sued. What you have to do is you run the data, you watch the behavior, and then you try to extrapolate what the rates of decay are, or the rates of increase are. So what if you didn't know that the rate was 1/2? Could we still extrapolate the rate of 1/2 from technology? The answer is yes. Now watch what I do first. because it will generate an error, the same error I got in class on Monday. So watch what I'm going to do. I'm going to go to calc. First of all, I'm going to take this equation out, but that's not important. I'm going to go to calc, and we already talked about linear regressions and quadratic regressions. I want to wander right down, all the way down to exponential regressions, EXP-REG. Now watch the error I get. Watch the error I get.
What?
Sorry, I used the wrong data set. I used L1, L2, not L5, L6. Sorry, hang on. I used the wrong data. I gotta go L5, L6, Y1. There we go. That's the same error I got on Monday. It says domain. Who remembers what a domain is mathematically? Do you remember what a domain is mathematically? Please!
It's the coordinates on the x-axis.
Good, it's the values that go in for x in an equation. It's a fancy, there's the domain and the range. I'm sure you've forgotten this. And I'm not gonna bring it back up except for right now. But the domain are the values that go in for x. It's telling you you've got problems with your domain for x. And the reason is, we just got done saying, I'm gonna quit this error for a second. We just got done saying that y itself, hello, I don't know what you are, that y itself, I have no idea what that is actually, that y itself can never equal 0, right? So we're trying to make the TI make an equation where y never is equal 0, except some of our y values in our data equal 0. So we're asking it to do something it mathematically can't do.
Oh, okay.
So what we have to go in is and remove all of the data points where y equals 0.
Oh.
Just go back into your data and clean it up, right? Go back into your data. That's so cute. It tried to.
That's so cute.
So we got to go into our stat editor and remove all the data points where y equals 0. It doesn't matter that we're doing this, because even with them removed, watch what it, once you remove the ones where y equals 0, regraph your data. It's not going to look that much different.
Oh, that's why.
Make sure you get the x values too, guys.
Oh, no.
Take the x values with them.
Oh.
So 9, 0 has to come out, 10, 0, 11, 0, 12, 0.
Is that delete? 13, 1.
13, 1's okay. 13, 1's okay, because it doesn't equal 0. The TI is not going to get pissed with that.
How do we
The
clear that?
DEL button. This is one of those not often used commands from that booklet.
Oh, I missed that.
How do you actually get in there? And you press the DEL button and gets rid of them individually.
Oh, it did it that time.
Can I see the data again?
Sure, all it did, Marion, was I took out 9, 10, 11, 12, and 0, 0, 0, 0.
That's what you did, no one.
That's what, let me see what you did, my friend.
There you go.
That's what you did. Good answer. Good answer. I like that.
I erased this and then it just moved.
Oh, okay, so we're going to do this. Let's just do this.
I think my numbers messed up.
There you go. You're not reading the book, it's still there, right? Yeah, 54111. Yeah, you're golden now.
Mine says dim mismatch.
Ah, that's because we got it's off a little bit. Let's go find out why.
Why does my 13 say 0?
Because you scoots down. You have to
Just change it to 1. Just change it to 1.
There we go, we're good now. Oh, I know what you did. You actually typed in
Down, yeah.
over the zeros, didn't you?
7, 8, 13.
That's okay. Hey, that's okay. The problem was then you had this tail of data. Yeah, not a problem. Once you've done it, press the graph button. Make sure you're getting the graph like mine up here, yes? Hey, what's up?
Dim mismatch.
That's what I said.
I just did a zoom stat that time. Zoom 9 every time. Zoom 9 every time. What that does, it gives you a window to your data.
Okay.
Yeah, that's, and again, that's
I don't
something.
know how I got that.
Don't you worry about it. Don't you worry about it. You mismatch, that means you got your lists in the wrong order. Everything's good, looks good. Oh, see, you got some extra values over here. These have to come out too. You took out all the zeros, you also have to take out all the x values associated with those zeros. Yeah, now the graph looks the same, doesn't it? Yes! Once you've got that set up, friends, run that xpreg now. Run your xpreg now.
Oh, delete that. Well, that last one was weird.
Okay, we so far? Jerry, no, what's up? Argument, that's cool. Go here. Go to that number 2. Oh, it's Y1, not L1. You're trying to put it in Y1, right?
Do you have to do that stuff? 'Cause I don't.
No! No. Ashley's asked a good question. It's been asked before. I like the fact that it's asked multiple times, actually. You do not have to actually store your equation to Y1. You don't have to. I just like doing it because then I can graph it with my data and be like, oh, look, it looks really good. Now, we know it's going to look. Did you guys already do it? It's already stored? Okay, good. So I'm gonna do it with you.
Do what?
Store, I'm going to do the XReg that I got an error on last time. XReg, exponential regression.
Oh, okay.
And I'm going to stick it in Y1. I keep using the wrong data list, sorry.
Where are you going to stat or bar?
That's going on.
Hang on. Where is my data? There is my data. What is the problem? Hang on, guys. This is pissing me off now.
Bars and then just over 1. Yeah, you have to go bars.
You're getting that too? Okay, good. The numbers don't look right to me, but you're getting this as well.
Yeah, I got the same.
Okay.
Looks good.
That's okay. Now, press graph. It just came in much lower, that's all. It just came in much lower. Does that make sense? So now, what we've learned from this, you can get an exponential fit for your data, but only use this regression after the fact if you can't figure out what the percentage is in your data. Our fit was much better. Wasn't ours much better, the 186, 1/2 to the x? Of course it was, because we were able to figure out what the average maintenance rate was. The TI can't figure anything out. It just looks at the data and goes, this is my guess as to what it is. It doesn't do the math that we did by the divide by 2, divide by 2, divide by 2, divide by 2. So no, it doesn't know, it's context-less. All it does is it feeds numbers into a formula and pops out a result. So the reason I bring this up is, XPreg is fine, except for the fact that it will miss the obvious. That's why you don't go right to the machines. You use this as a last case, a last resort. I want to illustrate, it doesn't make sense, that's okay. That's why I gave you a deck of cards. That's why I gave you a deck of cards, because we're going to do this twice again with the cards now, like the coins. But does everybody see the problem with XPreg? Why you had to remove some of the data points? Okay, good. So don't worry about that right now. If you can figure out what the model is without technology, you're usually going to get a better fit for it than with technology. Fair? Fair, maybe. Okay, maybe. Let's come back to that.